Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 53 and the difficulty is rated at is medium. This problem was asked by Apple and this is dumped right into the problem description. So we need to implement a queue using two stacks. Recall that a queue is a FIFO or first in first out data structure with the following methods. An enqueue method which inserts an element into the queue and dequeue method which removes it. Cool. So fortunately, we were able to find a similar problem on Lead Code, and let's just visit that. And the name of the problem is implement queue using stacks. Um, as mentioned before, I would sort of urge all of you to pause this video and check out the link given in the description below and try solving this problem on your own. This is a pretty easy problem and it's been rated as easy in lead code as well. But what you need to notice over here is that most interviewers will not tell you that you need to implement the solution using two stacks. Rather, they'll just say that you need to implement it using stacks. Um, but let that be aside, let's just go through problem description and we need to implement the following operations of queue using stacks. And over here, we need to implement four basic methods: a push method, a pop method, a peek, which sort of gets the front element, and an empty method which returns whether the queue is empty or not. Cool. And obviously, we know for a fact that this needs to be implemented using two stacks. But the reason behind this is that a stack is a data structure or an abstract data type which sort of works on the paradigm of a leaf-4 structure. So if we just say that we have three elements which are which we have, let's say 1 comma 2 comma 3, and we need to convert them or sort of use them as a data structure as a queue, and the only thing that we have is a stack. Let's just say that we have stack 1 and we have stack 2. Now the problem with the stack is that if you sort of push in elements and push and pop inside a stack works at a complexity of 1. So if you do a push, right, like you can do a push, which is a simple append inside a list in Python, and you can push all those elements inside your stack. It's pretty simple, but the issue over here is that you cannot pop out the first element which you have inside your stack. Rather, what you can do is you can pop out the last element and then you can move on from there. And for stacks, that's just the way it's sort of implemented as well. You need to pop out that element which has been, which was the latest value which was given to you, and then move on from there. So if you have to fetch out first, which in our FIFO paradigm you have to go from 1, 2, and 3, whereas over here the way we're going will be 3, 2, and 1. So the way to sort of go about it is you could basically pop out all the elements of S1 one by one and then append them inside S2. So let's just do that. You do a pop of 3 in S1 and push it inside S2. You pop out 2 inside S1 and push it inside S2. And then you pop out 1 from S1 and then push it inside S2. Now, as you can see over here, this thing has actually been reversed, but since it's using a LIFO paradigm, this value, which is the latest value which you've got, is the first value which you'll be getting. And the order is basically maintained. So your FIFO order is maintained, and that's the way to sort of go about it. Now, there are various ways to implement this two-stack approach, and today we'll be using a more amortized approach. If you don't know what amortization is, it's basically that you know for a fact that since we're doing the popping and pushing operations, it's going to be running at a complexity of O of n. We know that for a fact, so theoretically it's going to be running on in O of n, but what amortized solution suggests is that you can reduce the number of times you perform an O of n. So as you could see here, the one way to sort of go about it is you could sort of do that in a push operation or something like that. But we would not be doing that, or you could actually do it in a pop operation, but we will not be doing that, and we'll be maintaining two stacks, and then we'll be leveraging those two stacks and then moving forward from there. Cool. So let's just get down to the implementation, and this is going to be really quick. So let's just say that, oops, let's just say we have two stacks. We'll just call it self in stack and self out stack. Now what we'll do is we'll maintain a function which can perform all these push and pop operations that we sort of already described. So we'll call it move. And over here what we're going to do is it's just going to check whether there are some values inside your out stack or not. If there are any values inside your out stack, it's not going to do anything. But if there aren't any values inside your out stack, what it's going to do is it's going to pop out all the values from in stack and then append them inside your out stack. So let's just do that. We'll just say, hey, if your out stack is empty, then you need to push in all the elements from in stack. And the way to sort of go about it is you can run a while loop on your in stack. Basically, the in stack has some elements, right? And now all you have to do is you just need to append all the values while you're popping out the values from your in stack. So you need to append on your out stack while and whatever you're appending is basically the value which you've just popped out from your in stack. And the way to do that is like this. If you didn't understand what's happening here, basically you're popping out a value from in stack and you're just appending it inside your out stack. And this way what happens is that you really don't have to make that move or sort of that update every single time or a pop. Rather what you do is you just sort of make sure that you do this operation whenever you're inside your whenever there's something inside or not inside your out stack. Cool. So your push operation is going to be very simple. All you have to do is inside your in stack, all you have to do is you just have to do a simple append, and you append the x, basically the variable which has been passed as a parameter inside your push method. For your pop, all you have to do is you just have to make sure that whatever you're popping is the correct value that you're popping, and you know for a fact that out stack has the correct value. So all we have to do is we just have to do a return of self dot out stack and just do a simple pop. Now an out stack might be empty and we might have to do this operation there, so we'll just call self.move before that. So let's just do that. Self.move needs to be called before we do a pop. So this way what happens is that just before you're doing your out stack pop, you need to make sure that the out stack has some value. If it has a value, it's obviously going to be in an ordered way, and then it can just pop out that value. If there aren't any values, what's going to happen is it's going to take all the elements from your in stack, push them inside your out stack, and then move forward from there. A similar approach for getting the peak value. The peak was, again, we need to get the front element. So all we have to do is a simple return. But before we do a return, we just have to make sure that there are some values inside your out stack. And now we just have to do a self out stack and return the last element. The way to do that in Python is just by giving -1, and that's the way to go about it. Empty over here is just a function which returns whether the key is empty or not, and this is very simple to just write down. You just have to do a return call of whether there's some value inside your in stack and whether there's some value inside your out stack. And basically this would denote that whether the queue is empty or not. And that's basically it. There's not much here to do it. And again, the amortized solution over here is just the fact that you're making sure that you're not doing the push pop operations all the time. The only time you would do that if there are is that when there are no elements inside your out stack, and then you just push all the elements inside your in stack, and that way you can sort of reduce the number of times you do these push pop operations. Cool. Let's just run this code. And awesome, you can see that's running. The output is the same as the expected output, and there's not much here. We can do a simple print as well. So let's just do a print of before and after just to see how the out stack and the in stack is working. We'll do a quick copy paste here, and let's just make this after, and let's just run this one more time. So over here, the the operations are you're pushing in 1 and 2. So what's going to happen is that inside your in stack, so peak has been called, and since peak has been called, you need to know that self.outStack is the one that we want values under. So we do the operation, we check that self.outStack does not have any values, and basically what we do is inside your in stack, we pop out all the values one by one, and we push them inside your out stack. And that's basically it. There's not much here to it. If you're having a little bit of a difficulty like visualizing this, you sort of think about this as a container or a series of blocks, and all you can do is you can just pick up the last block from your container. So if you have two containers, that way whatever that you're putting in inside, that thing will always be the one which will come out first. Cool. So let's just submit this. Hopefully this should run fine. And awesome, you can see that it's running faster than 64% of the Python online submissions. It's not really important. What's more important is how you're implementing it. And memory wise, it's not the most memory efficient solution as well, just because you're using two stacks. But that's basically it. There's not much here to it. In an interview, whenever you face this problem, The way to sort of go about it is just that you make a simple move method. A move method can be leveraged easily to just push in elements inside your out stack, and then basically you can move on from there. And also, if you had any comments or if there's something that you did not understand, do leave it in the comment section below. I'd love to handle any of your queries. And if you did like this video, do give a like and do subscribe to the channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have an awesome day. Thank you.